So in this video we are going to talk about microservices. Okay, so firstly, before starting with microservices, first let's understand what exactly is a monolith. So like monolith is originally something how usually applications used to be built. So consider this as a single code base, okay, which is connected to a database. Okay, this is your database and this is your single code base, which could be written in like Java or any other technologies of your preference. Okay, so what used to be done is like this instance of the application used to be deployed on a web server. Okay, so web server used to be there, and web server used to manage the incoming and outgoing connections. Okay, so like web server would be connected directly from the client. Okay, so this was how originally applications used to be made. So like your application is deployed on your web server and the client communicates directly with the web server. But the problem with this approach is we are bound to the machine constraints. Okay, so here if your machine has like 2 GB of RAM, okay, and let's say you have like 2 cores of your processor, so you have a dual core processor and a 2 GB of RAM, so like that is the whole constraint of your system. So like once your user base increases, okay, so what you will have is like your server would have like denial of service issues. So like your application would not be able to process, so it will throw different types of errors. Sometimes it will show you bad gateway errors or sort of a thing. Okay, so like these types of errors will be very common as you reach your threshold limit of your hardware. So in such cases you have two options. Okay, so like one option is to scale vertically. So like what vertical scaling means is you increase your hardware. Okay, increase your hardware, so scale up your hardware. So like if you have a 2 GB RAM, you opt for a 4 GB RAM or 8 GB RAM or vice versa. Okay, so you increase your hardware accordingly. So that is one strategy that used to be followed. And second strategy is horizontal scaling. So like the horizontal scaling can be done in two ways. Okay, so one way is like have a managed server connected over here. Okay, so this server acts as a API gateway, okay, or like gateway for all sorts of things. Okay, and then from this gateway or this server you will be connected to multiple different servers, let's say S1 and S2. Okay, and this server will also act through this API gateway. It will also act as a load balancer. So this does all the duties. Okay, and database in this case can be a single database instance or a replicated copy of it. Okay, so this is something that could be done. This is one approach of horizontal scaling, okay, which does not involve any microservice or anything at all. Okay, so this is the classical approach, like you are replicating the same code into two different instances, and one server or any of these things is managing your API gateway and load balancing. Okay, so this is one configuration, but this also has a bottleneck. Okay, once you reach a certain threshold you wouldn't be able to scale this thing. Okay, so that is also another problem which you will face. So another horizontal scaling approach that currently we use is called microservices. Okay, so now speaking of microservices, let's just get started with the history of microservices, or rather let's just first see how actually microservices decomposition works. So like if you have a e-com website, okay, e-commerce website, so you would have a catalog of products, okay, you would have orders, and you would have procurement, okay. So when you're connected to ERP and sort of thing, so procurement will be taken care of through this thing. So like new products or new this thing, raw materials that you're taking in will be kept over here. Then you will have orders, and then you have catalog. So like these three distinctions, or you could say these three different topics, could be turned into services. So catalog service, order service, and procurement service. So you could turn them into services, and these three could act as independent units, okay, and these independent units would communicate with each other, okay. So poor drawing skills, okay, but yeah, so a communication channel between them could exist, okay. So how actually this is accomplished, okay, so this is the microservices way of things. So like we are just looking it into a brief this thing, or you could say a bird's eye view sort of a thing, okay. So now we'll get into the intricacies of how this thing works. So here between the services, you could either have something called as RPC, that is the remote procedure calls, or you could have something called as MQs, okay. MQs are message queues, so like they could pass the messages between the services. And another thing is like remote procedure calls. So RPC based methods are synchronous methods, okay. So like these are blocking calls, okay, and the MQs are predominantly asynchronous, okay. So like you usually do not have a, you could say, a blocking call whenever you're using message queues, okay. So message queues, and there are also something called as event streams, okay. So like very popular event streamer is, which is very popular and used a lot, is called Kafka, okay. On the MQ side of things, you have something called as RabbitMQ, okay. And for RPC you have something called as gRPC, okay, which is provided by Google, and it works at a binary level using protocol buffer, okay. So protobuf, that is the protocol it uses. So basically it calls remote procedures and returns the output through a binary channel sort of a thing, okay. And MQs are basically message queues. So they are like, they pass messages between services, and based on the messages you have to do some sort of execution, and synchronization works between them, okay. And event streams are like, you have message packets, or like through API gateway you have multiple number of clients coming in. So those clients requests are stored in sort of a stream. So whenever you want to consume that stream, you can consume it. So like that is how it works. So like we'll go into details in some other video, but this is how we can bind all the services together, okay. And now at the higher level, if we check, just a second, the protocol that is usually used to bind the different services is called AMQP, okay, Advanced Message Queuing Protocol, okay. And the implementations that use this protocol, okay, so those are Cupid, Apache Cupid, okay, QPID, which is called. Then there's ActiveMQ, which is another very popular message queue that is used. And there's also RabbitMQ, which uses AMQP. Okay, but RabbitMQ can use MQTT and HTMQ protocol as well. Okay, so RabbitMQ is pretty much flexible in that aspect. Okay, and so the whole microservices thing has evolved basically from two different things. Okay, so let's just get into some sort of history. Okay, so originally there is something called as ORB. Okay, like this is the thing of like late 90s or 2000 sort of thing. Okay, so this is object request broker. Okay, this was the standard object request broker. So this needed some sort of implementation. Okay, so that implementation, or you could say this was a standard, and the implementation that was very famous, or currently it exists, is called CORBA, Common Object Request Broker Architecture. So this CORBA thing was like, you could say, a remote method invocation system, RMI, what you call. Okay, and this worked basically at a object level. So like you had defined contracts. Okay, so like services and contracts were defined, and based on that you had, you could say, parameters were set, and you could call the remote functions. Okay, written within, you could say, different technologies. Okay, and the output used to be serialized, or you could call it marshaled, and sent as a binary object. Okay, so here the complete object used to be sent, and this was completely a OOP based system. Okay, so like languages like Java, CPP, and sort of things were the main things that were involved in this thing. Okay, predominantly Java, you could say. So object oriented programming based, so complete object used to be serialized and sent back and forth. Okay, and this is how ORB worked. Okay, so after ORB there was something called as service oriented architecture. So like service oriented, and just a second, handwriting is a bit. Service oriented architecture. So service oriented architecture was a, you could say, a transition between ORB and like microservices. So like this was ultimately between the two. Okay, so in service oriented architecture there was something of a requirement of an enterprise service bus. Okay, so like predominantly this was the core of it, enterprise service bus. Okay, so enterprise service bus implementation currently, that is, like you could find a easy example would be of a MuleSoft. Okay, which is a enterprise service bus, and AWS also offers some sort of enterprise service bus type of this thing, but most of it is used at legacy level. Okay, so why actually this service oriented architecture was used is like compatibility between the technologies. Okay, compatibility between technologies. Okay, So what this ESB or the enterprise service bus did is, like, if you have an application, okay, you have an application, okay, and like this application, let's say it works on some like stocks application, like stock market, okay. The data will be sent in different formats. Let's say one application that is consuming your data needs it in JSON, other thing needs in XML, and some other thing needs it in, let's say, REST API. So again JSON, bad idea, XML, JSON, or any other sort of implementation, okay. So initially, when you didn't have this thing, service oriented architectures or ESBs, what used to happen is, like, the application code in itself, okay, code in itself was responsible for the data transformations, okay. So the ESB basically provided the routing, okay, to different channels of where the data was required. Then it provided the message transformations, okay, message transformations, and authentication, okay. So whatever service wanted to access the app data needed to be authenticated, okay, and there was logging of the data as well. Whatever data was accessed, or like whatever data was sent, so it was logged. So this complete architecture has just been done with an ESB, okay. Rather than the complete application code, we could use an ESB which will take care of the data transformation or message transformations, okay. So that is the main reason why enterprise service bus and SOA were like used, okay. So the problem with SOA was, most of the services that were present in the SOA architecture usually were macro services, not rather microservices. They were macro services, so like bigger services. So like the distinction, or you could say the, what you call, the decomposition was not at a micro level, okay. So it was like the services were bigger only. And another problem was with the ESP. So like the enterprise service bus had like the lots of dependencies, okay. So like if your ESP has any faults or any type of this thing, your whole system will be down, okay. So like that was a major issue in the service oriented architecture. So it was not completely, you could say, decentralized, or you could say separation of concerns were not clearly defined in this architecture. So that was yet another smaller issue which could be a bigger issue once your application grows, okay. So the microservices help, okay, in making things like separate. So like you could have like multiple different services running independently. So like if one service fails, that specific service is going to fail, okay. The other services are still running, okay. And whichever the workload or like the load balancing thing was easier in microservices. So like whichever services get more number of hits, like this service is getting more number of hits like compared to other services, lot of these things. So what you could do is replicate this service, okay, replicate multiple copies of this service. So how this is done? This is done using something called as a containerized environment. So one of the most famous containers, the containerized environments currently being used is Docker. Okay, so when Docker comes into picture, the orchestration, or you could say the deployment of the application, is done in certain way. So like individual parts are into Docker images. So like you have a PHP code in one Docker image, okay, Docker container, not image, sorry. And then you have your front end, which could be in React or Angular, okay, in one container. And then you have your database, okay. Usually databases are not put into containers, okay. Sometimes they are put into containers, but usually databases are kept separately. So like you could have a replicated database, okay, and the read replica you could have, or a synchronized cluster you could have, okay. So these both databases are synchronized. You could use either of the two, okay, both of them, okay, depending upon how you access it. Okay, sorry, the React is not supposed to access the database directly, sorry. So it should access through PHP, and that is how it works, okay. So even with the containers, you need to have a deployment plan, okay. So like the containers should scale in real time, okay. So what happens if suddenly this service gets a lot of hits, okay. So you should have a dynamic scaling plan. So such a dynamic scaling plan for Docker is provided by something called as Kubernetes. So this will take care of the dynamic plan of how scalability is to be ensured, okay. And another thing, that is the important part of this thing, is like you have created this thing, okay. So nowadays we have something called a service mesh, which takes care of the communication, or you could say provide the endpoints for this thing. So service mesh is another important part of the microservices architecture that we use, okay. So popular, you could say, service mesh implementations is Istio, okay, and Kong. So like these are the two predominant, you could say, service mesh implementations that are currently in use, okay. And like this is how an enterprise application works, or you could say a microservices based application works. So this was like a overview of how microservices, or pure introductory part of how microservices or the whole ecosystem of microservices could work, okay. So we could get into details of individual components, parts, or that sort of a thing in our upcoming videos. Thank you.